We're going to approach this welding video in 4 parts today. We're going to first talk about welding safety, then we're going to talk about our machines and welder setup, then we'll do some steel welding and talk about the clamps method. So let's start with safety first. So the first thing you want to do when you come back and get ready to weld is you want to make sure that the curtain is closed all the way around. You want to make sure that your table is clear of any flammable materials. For personal protection devices, I would recommend leather shoes. I would recommend that you wear a natural fiber instead of a synthetic. The synthetic fibers can melt if they get a spark. We're going to use a welding jacket. So you want to make sure that it's one that the sleeves aren't too long or the shoulders are too narrow. They button up. You don't necessarily have to make all of the buttons. So if your jacket you pick happens to have a button that's missing or something, don't worry about it too much. We're going to have 2 kinds of gloves back here in our shop. We have this thinner glove. This is a TIG welding glove. I don't recommend this for MIG welding. I would prefer that you wear the thick gloves like this. Now we do have several different helmets back here. They're all auto darkening helmets like this. So that means that once you start to weld, they automatically go dark on us, so you don't have to do like you see in the movies and flick your head and make the helmet come down. And looking on the inside, you will find either the on button like this, the reset button like this, or the reset button like this helmet. You'll want to point these helmets at the light. You'll want to press that reset button, and you'll want to make sure that the helmet blinks at you. Adjust it to your head by pushing in on this knob and turning it. We're going to be welding 2 different materials today. We're going to be welding steel and aluminum. At the end of the day, our goal is to be able to produce 2 pieces like this, a corner weld and a T-weld. When we set up our welders, we're going to be using what's commonly called a suitcase welder. That's these small welders here. They're called a suitcase because they look like a suitcase. When you come to the welding lab, they will be ready to go. Wire is loaded on a big spool. It's got a drive mechanism here. The wire is pushed up through the hose all the way to the welding torch, where it comes out the end over here. For aluminum, we use what's called a spool gun because it obviously has a spool back here. So this feeds right here from this spool, but it still comes out the tip just like the other one, where the gas comes out and the electricity comes out in the front. Our on switch is located on the back of the welder. Here on the front panel, we have a material selector knob. We want to make sure that the blue light is on that says mild steel, if this is the one we're using on steel. And then these 2 knobs here control the voltage and the wire speed. Now all of these welders have a setup chart on the inside. It's just like this one here, and it's relatively easy to figure out what you need to do. First thing you need to do is look at what kind of material you have. We're going to be welding steel. We're going to looking at wire type. We're going to use solid wire, ER70S-6 wire. We're going to use it as shielding gas that is 25% CO2, 75% argon. We're going to use 035 wire, and we're going to be welding 18 gauge steel. So that tells us, if we follow this across, it tells us that our welders should be set at about 3 and 30. The top number is 3 is the voltage, the bottom number 30 is the wire speed. Now those, we'd come over here and set these knobs at 3 and 30. This one's already set there. If we were doing aluminum on the spool gun, we would come down to the aluminum. We're going to use 4043 wire. We're using 100% argon. We're still using 035 wire. We're still at 18 gauge. And this says that we should start at about a 2 and a 65. The last thing we have to do in our setup is turn our gases on. These are our gases over here. The gold bottle is called gold gas. It's our steel mix. It's our argon CO2 mix. This brownish bottle is our argon. It's used for the aluminum. These are non-explosive gases, so you turn the knob all the way on, back it off about 1/4 to 1/2 of a turn on both of them, and then you want to set the flow rate to about 25 CFM, which means that on this one, on the argon case, there's a steel ball in here. When we pull the trigger, we want the center of that steel ball to be at about 25. Same thing over here on this one. Because this one is 75% argon, we want to use the argon side for our 25%. And as long as we're in between those two, we're okay on that. It says that our gas flow rate should be 20 to 30 CFM, so we just pick the one in the middle. So we've got our welder set up. We have all of our material out. Let's get ready to weld. I've pre-cleaned some parts of material. We're going to look at the clams method of manipulating our arc. So we're going to be using current, length of arc, angle of the electrode, whether we're going to forehand or backhand, manipulation of the weld puddle, which means whether we run our torch straight along a line or whether we angle it back and forth a little bit, and speed of our welding. I'm going to make a tack weld here, a tack weld here. That does two things. One, while I'm practicing, it gives me a target to shoot for as I come across. It takes the material and keeps it from spreading apart like this as you weld across. If I just start welding here, by the time I get down here, the metal will have pulled apart and I won't be able to weld across it. The person that's holding the welding torch is the one that's responsible to make sure that everybody's welding helmets are in place before they start welding. I want you to make sure that you tell all of your teammates that they need to go helmets down before you start welding, and that you look and verify that their helmets are down before you start welding. So the first thing we want to look at on our weld is that we can see that our width is relatively constant. That's good. That means that our speed is relatively constant. If we were speeding up and slowing down as we came across the weld width here would go wide and narrow. Narrow when we go too fast, wide when we go too slow. We're holding a consistent height above the piece. We can tell that because we can see that the height of the weld all the way across is about the same. It's a little high here. My torch was a little high. I know that for a fact, and I was a little slow as I started there. Typically it happens when you first start if you haven't run a few practice welds to start with. But other than that, it's not too bad. There are no inclusions in it, no air bubbles. I didn't have any pops or sputters. The weld did have that frying bacon sound, which is what you're looking for when you're making a MIG weld. And you can tell that I started here and actually went a little slower as I got across, so my penetration went up. We want to avoid penetration like this here at the end. That much penetration can contaminate the backside of the weld, and if this was a structural piece, that could give us a poor weld to start with here. So this is the two most common problems I see when students are doing the Weld Lab back here. When they first start, they're a little intimidated by the welder and they tend to go really, really fast. And when they go really, really fast, we get this. We get this weld that looks like this. It's just a string of wire that came across the top. And if we look on the bottom, there is no penetration at all. Then we go to the other extreme where we go too slow. Our weld is very fat. It's very tall, and yet we still have a whole bunch of penetration down here because we're going too fast. Again, if I could look at it sideways like this, the amount of excess material on the bottom here is probably 2/3 of what that is there. So when you come down to practice this, you want to change one thing at a time to find out what you are and work within a narrow range, because the factory has done a lot of research to find out what makes a good weld for these and what doesn't. Let's try welding some aluminum. I have our welder all set up based on the factory specs from the door. Now the aluminum is very prone to contamination, so when I wire brush it, I do not want to wire brush it across the table because the steel from the table will contaminate my aluminum. So I'm going to use a piece of spare aluminum that I'm going to put down when I wire brush my aluminum. Our gun is different from the aluminum than it is from the steel. The aluminum likes to do forehand weld more than backhand weld. Aluminum also likes to be much more straight up and down with very little tilt in it as you go across, so you can keep that shielding gas in there. It also tends to help to have the torch a little closer, maybe 1/4 of an inch to instead of 3/8. The welding setups for aluminum, in this case the factory settings are 2 and 65. The wire speed is twice that of steel, which means that no matter what I do, I'm going to have to move this gun faster in order to make a decent weld. The aluminum melts at a much lower temperature, and so I've got to move faster in order to not blow a hole in it. So let's go ahead and try this. I've got it set at factory settings. I've got all my safety gear on. Let's go helmets down and let's give it a shot. All right, let's take a look at that weld. I went much faster here than I did on steel. So my weld looks okay. It's relatively consistent. You can see as I get down to this end, I've slowed down just a little bit because my weld is getting flatter. And you can see even at that speed, because I'm not consistent, down here where I'm flat, I'm getting much more penetration. Up here where I'm a little faster, I'm not getting as much penetration, but all in all, not too bad. Let's try it again and see if I can get a little more consistent. Helmets down. This looks okay. Let's look at my penetration. Much better on my penetration. It's a lot more consistent. Now you may find on the aluminum that you have to make a significant change in the wire speed before you figure out how to get a consistent bead out of this. Way too slow, we're blowing lots of holes. Let's try speeding up just a little bit. Again, I'm blowing holes in it. A little trick I'll tell you about is make sure when you're welding, don't put your test weld over top one of these holes, because you're more likely to blow all the way through it. On this last weld we did over here, that may be why I blew these holes, because this plate is now warped and those pieces were up off the table, and so I'm more likely to blow a hole through it. And let's go helmets down and weld. No holes that time. Weld looks okay. Not quite enough penetration, maybe going a little too fast. Let's brush it quick. Let's try it again. With aluminum, even with steel, it's all about practice. Practice, practice, practice. So let's try another weld. Speed is pretty consistent. You can tell that by looking at the width. And then you can see that I'm just about dialed in. My penetration is just starting to come through. Remember, at the end of the day, you need to make either an angle joint like that or a T-joint like this. I've gone ahead and prepared some pieces of steel to work with so that we can do our corner weld. We're going to start with an inside corner first. We want to make sure, I'm going to use the magnets because that's easy for me to really hold this stuff square. Make sure your fit up is good. You can have it. Let's go ahead and give it a brush again, just to make sure we don't have any contamination in there. We'll get a better weld out of it that way. And let's see if we can get a decent weld out of this. So now I'm going to try and manipulate my torch up and down a little bit. Now if I look carefully at that weld, while I was welding it, I can actually see the puddle along the back side that's forming on that. So let's look at what the weld looks like all together all by itself. Weld width is relatively consistent. It's not perfect, but it's okay. I got a little spot right there. And if we look at the back, we can see that I have evidence of penetration right through the corner. It looks like most of my heat is going on the top. Here's where there's the heat affected zone there, a little bit more than I have on the bottom. Let's give it the stomp test. And I look to see if I got anywhere where the weld peels apart. And you can see on this one, I don't have any peel apart on it. So that's a pretty good weld. We'll leave it at that. Let's try an outside weld now here, and I'm going to try and weld across this area right in here as best I can. Now remember, you may not get weld coming all the way through the material on this. When you're welding at an angle like this, you're actually at the hypotenuse. And crack weld. Again, I'm giving a little manipulation of my torch to try and make sure I stay up on the top of that weld. Now if we look at this weld, it doesn't look too bad. No holes blown through it. It's a little heavy down on this side. I was a little slow there, and sure enough, if you look on the inside here, you can see I'm a little heavy on my penetration, but my penetration is almost down exactly in the corner. Not quite all the way in the corner, but it's pretty close, and I've got a heat affected zone on both sides. And I'm going to set up for my T-weld here. I'm going to cut off my wire. I've got my setup ready to go. Let's give it a tack weld. So you can see that I've made a wider weld in through here in order to bring my heat up. Down on the bottom, you can see the line across the bottom where I'm starting to get penetration. And if you look really carefully, I'm not quite deep enough into the corner there, but all in all, that's not too bad. I don't have to tack weld again on this side because I've already tacked and welded it on the other side. Just a quick look at it. Doesn't look too bad. I'm a little thin. It's not as flat as I would like it. My penetration, you can see I'm just starting to get the line across the back. Let's try one more piece and see what we can get out of that. Again, I'm going to take get my tack weld. Here at the beginning, I didn't get my arc started well. I got it pretty good across the back right here. You can see I have a fairly spread out weld. If we were to cut that open, we can see on the back, I'm getting some penetration back here. Don't have a lot in the bottom. We're just going to brush it and weld the other side. Let's look at this weld. Again, you can see that now I've got a much wider weld going on. With aluminum, that's usually important. I am bunching up a little bit, but I can see where I'm starting to penetrate here. Doesn't have any blow-throughs. I bet you if we did a stomp test on this, stomp test shows that we bend across the weld. Manipulate the torch across here to get a little wider weld to make sure that I can stay down in that corner. It's very difficult to get the wire to stay in the corner, so by moving up and down like this across the surface, it's easier to get the wire down inside there.